prompt template, which is going to be sent to a Chat NVIDIA LLM instance, and then is finally going to result in a Chat NVIDIA output, kind of as we would expect. As an additional helper method, chains have an input schema, and you can invoke its schema method. And this can be helpful because what it shows you is, specifically in this required property, what parameters in the chain are required to be populated when we invoke this chain. Again, we have a simple chain here. It's very straightforward for us to kind of look up and see. We've got this one parameter question, but as your chains get more complicated, as you start working with other people's chains or chains that have been defined elsewhere, it can be really helpful to introspect this input schema method to get clear on what the chain itself expects. Please excuse me. So this object here is actually a Pydantic object. We're going to look at Pydantic in more detail in a later section where we talk about structured output. For now, you don't need to worry about it too much. But one thing about Pydantic is it can be used for data validation, and this is, again, where we're seeing that this particular chain has a required property, namely the question property. Okay, so we know now, right, that chains are composed of runnables. In this case, we have two runnables, our prompt template and our LLM instance. However, chains are actually runnables themselves. And what do we know about runnables? We know that they can be invoked. So given that the beginning of our chain expects a prompt input and that the prompt template expects us to supply a value for a question, we can invoke the chain while providing the expected value. So here we're going to take our chain and we're going to use the invoke method on it. We're going to supply the value for the question property that it expects. Please excuse me. And you can see that we get back a response from the large language model. Again, we are probably most interested in this content field. So let's invoke the chain again and store it in an answer variable and print out the content of the answer. And you can see our question, who founded NVIDIA, results in NVIDIA was founded in '93 by Jensen Huang, Chris Malachowski, and Curtis Prim. Okay, so what's happened is we've taken multiple pieces of functionality, namely formatting a prompt template, and then chain that directly into invoking the large language model. Before we learned about LCL chains, this would have been a multi-step approach where we would have had to invoke the prompt template first and then taken that prompt and used it to invoke the LLM instance. But now we can create a chain where we only have to invoke it once and feed the values of the first part into the second part. So let's continue. And let's continue with something called an output parser. It's another core LangChain component. And output parsers are classes that help structure LLM responses. Output parsers, just like the LLM instances you've been using and just like prompt templates, are also runnables, right? Which means we can use the runnable in the context of creating LangChain chains. So we're going to begin with perhaps the most straightforward output parser, which is called string output parser. And it's going to save us all the repetitive boilerplate of fishing the content field out of our model responses. In order to use it, the first thing we need to do is import it. We did this above, but for the sake of keeping it clear, you can see we'll import it here. It's available via the LangChain core output parsers. We'll be looking at other output parsers later in the course. And this is a class that we can now invoke. If we wanted to do something more complicated, there are arguments we can pass into string output parser. But for the most part, and what we're going to do here is we're just going to invoke it to create an instance of our output parser, which we'll name parser. So given our claims from earlier in this notebook that all runnables have an invoke, batch, and stream methods, we would expect to be able to call them also on parser, right? If our claim is that the parser is also a runnable. So let's just test that hypothesis. We'll take parser.invoke and we'll parse the string. You can see in this situation, all it did was parse the string. And we can also batch it with a list of outputs. And similarly, we get a list back with these strings being parsed. It looks like in this case, given a kind of a raw string, it didn't do any modification. But the point, and what I'm really trying to drill in with y'all right now, is that chains are composed of runnables, and in LangChain, all runnables can be invoked, batched, and streamed. Okay, so, and furthermore, runnables can be used to create chains, and that's what we want to do here. So we're going to redefine chain, again, starting with our template, piping it into our LLM instance, but now as a final step, we're going to pipe that into the string output parser instance that we created again, or that we created above. Again, we can look at our helper get graph methods, and you can see it looks very similar from earlier, except that after invoking the Chat NVIDIA LLM instance, it's going to go through the string output parser, and we're going to get an output that has been parsed by the string output parser. Okay, so let's go ahead and invoke it just like we did with our earlier chain, passing in the question. But you can see this time when we invoke the chain, this time we asked who invented the use of the pipe symbol in Unix systems, kind of appropriate to our topic. You can see we didn't have to do anything like .content here, right? Excuse me. We didn't have to save the value and then get the .content off of it. However, the response that we're getting back is just the parsed string and only the parsed string. So now we have a chain that we can reuse kind of time and time again, and it's been made very clean and convenient for us to use. Okay, so with all that in mind, we're going to set you out on an exercise to leverage what you've learned here and kind of get your hands dirty for the first time composing LangChain chains. So the exercise is, again, we're going to look at the translation task, which we did in section 1, and we're going to revisit it. The goal, again, is to be able to take a given statement, to specify the source language of the statement and also the target language of the statement, and be able to invoke the chain, right, with just the statement and get the translated output and only the translated output back out. Okay, so to do this, you're going to have to create a chain similar to the one that we created above. So give this a try. I'm going to pause here on the video. You should do the same while you work on the exercise. And then after you finish your work on it, come back, unpause the video, and I'll go over the solution that we implemented together with you. Okay, good luck. Okay, hopefully you had some success creating your first LangChain chain. Let's take a look at how we implemented this in the solutions section. To begin with, we started with a prompt template, which we're calling translate template. Our template says translate the following statement from language, which we've parameterized, to language, which we've parameterized. And we specified provide only the translated text. And we parameterized a statement that we actually want translated. Next, we create a translation chain. We use our translate template. We pipe it into our LLM instance, which we've created above, and we pipe it into then the string output parser instance, which we created above. Just for the sake of clarification, we will again look at the ASCII graph output of this particular chain. You can see it looks very similar to the one that we created a little bit earlier in the notebook. And again, to kind of drill in the availability of this schema method, we look at the schema, and you can see here this particular chain has 3 required fields, namely a from language, a statement, and a to language. With that in mind, we're now going to invoke our translation chain. We're specifying a from language, a to language, and a statement. And namely, we want to translate the English statement, no matter who you are, it's fun to learn new things, into German. And you can see invoking this chain, we get the German text and only the German text because of the presence of the string output parser. Okay, so in this notebook, you learned how to work with runnables. And in particular, three of the core kinds of LangChain runnables, namely LLM instances, prompt templates, and output parsers. Furthermore, you learned what it meant to be a runnable, and you learned that you can compose runnables in chains, and that chains are